Okay, this is section 10.3, intercepts. We talked about 10.1 was learning how to plot points, what we do with points, and how we can read graphs. 10.2 was talking about how to graph equations with any kind of point. So we chose points and we would graph it by choosing any point we want. Now, intercepts are types of points in a graph, but they represent where a graph intersects on the y and the x axis. So like, let's zoom in right here. Looking at these examples. It says, for the example 1, identify the x and the y-intercept. X-intercepts are where this line right here intersects this x-axis right here. So this right here is the x-axis. This is the y-axis. So whenever you're trying to find x and y-intercepts, you kind of want to scan the entire line and see where it crosses the axes. Axes is plural for two axis. So we have an x-axis and a y-axis. This right here would be our x-intercept. This right here would be our y-intercept. This one is called our x-intercept because it intersects with the x-axis. This one right here is our y-intercept because it intersects with the y-axis. And not all graphs have x and y-intercepts. Some have only one y-intercept, some have only one x-intercept, some have both, some have multiple. It just really depends on the graph at hand. You might find some graphs in college algebra that don't have an x or a y-intercept. There's all different types of graphs, but the easiest way to identify all the x and y-intercepts is to simply just scan the graph and look. So we want to trace out this line and see where they are at. So our x-intercept's right here. That would be at -3, 0. Our y-intercept is at 0, 2. So that's a linear line, the one that we just did right there. If we look at this one right here, number 2, this is a different graph. This looks like a hyperbola from, you'll probably learn those in pre-calculus, or it could be a parabola as well, but it looks a little hyperbolic. Anyway, this one, all we have to do is look at the line and we watch all the things that it crosses. So if we follow the line, we see right here is where it crosses the x-axis. So this would be an x-intercept. Keep following the line, and you see right here there's another one, -1. That would also be an x-intercept. If we keep following the line, here's another one, but it intersects with the y-axis this time. So our x-intercept would be -4, 0, which is right here. Then -1, 0, which is right here. And then our y-intercept is going to be 0, 1. So if you notice all of our x and y-intercepts, notice all x-intercepts, their y value right here is always going to be 0. So all x-intercepts are some kind of x number, and then it's 0, 0, 0 for all the y numbers. Y-intercepts are the other way around. Notice the x is always going to be 0, but the y value changes. That's because an x-intercept lies on the x-axis. It doesn't have any up or down movement, so the y coordinate is always going to be 0. Same thing for the y-intercept. For y-intercepts, the x is always going to be 0 because there's no left or right movement on an up and down graph. It only goes up or down. It doesn't go left or right. So your x is always going to be 0. If we look at this graph right here, that one on number 3 intersects right in the center. The center is where the x and the y-axis meet. That's called the origin. So we learn in 10.1. So technically that one point right there is both an x and a y-intercept. So that's why they're listed here as 0, 0 and 0, 0. If we look at number 4, this is a vertical line. Notice it doesn't actually intersect anywhere on the y-axis, right? It runs what we call a parallel to it. So it's not actually going to ever intersect the y-axis. So here we only have an x-intercept at 2, 0. Since there is no intersection at the y-axis, we would call this y-intercept none. There isn't a y-intercept whatsoever. And you might have graphs like that don't have a y-intercept, an x-intercept, or maybe both. They might not have either. It just depends on what the graph is. For all of our graphs that we're working with in this class, all of our linear graphs, they're always going to have at least one intercept. So, let's look at this one. I'm going to choose a little color here. All right. So here we can see there's our x-intercept. That one is going to be -4, 0. Here we see there's a y-intercept, so that would be 0, -6. That's all there is to it. This one would be an x-intercept. This one would be a y-intercept. If we look at the other graph, we see one right here at -2, 0, and we see one right here at 2, 0. Those are both x-intercepts. And then right here is where we have our y-intercept of 0, -3. And that would be our y-intercept. All right, so let's go ahead and jump over to the next example, example 5. So if we look here, this one is this elliptical idea. It's like a circle, but an ellipse. An ellipse is a slightly, it's an oval essentially, but we call it an ellipse in math. So if we look at this one, notice it has a bunch of different intercepts. Let's go ahead and zoom in really quick and make it a little easier. Here we can identify that it actually has multiple ones. Right here we got 0, 2. Here we have -1, 0. Here we have 0, -1. And right here we have 3, 0. So all of those are listed right there off to the side. You can see that they listed them. That's a circle, so it has 4 different ones, or an ellipse, multiple different intercepts. So if you look on these little graphs over here, try to zoom in here. Right here, we can see that this graph intersects once right there. And then this one intersects once right there. And here's another circle. Got one here, 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 and here. Multiple intercepts throughout the graph. Now, whenever we're talking about intercepts, so we could find intercepts. Usually they're easier to find, but what we want to do, they're easier to find when you're looking at a graph, but not all equations are graphed for us. For example, example 6. That one wants us to find the intercepts algebraically. So what we're going to do in order to find this equation algebraically is we're going to go over to a sheet of paper and start doing it by hand. Let's look at this. Example 6. It wants us to graph x minus 3y equals 6 by finding and plotting the intercepts. Now be careful when you do your homework, because your homework will either say graph the equation, or it'll say graph the equation by finding the intercepts. So really you can graph any equation in the method that we used in the last section by plugging in any random point. But be sure to read your instructions on My Math Lab. If My Math Lab says graph by finding the intercepts, you have to find the intercepts to graph it. So let's go ahead and make a little t-chart. For intercepts, remember x is going to be 0 for one of them and y is going to be 0 for one of them. So if we ever want to find a y-intercept, this would be our y-intercept. This one would be our x-intercept. Because remember, for y-intercepts, we make x equal 0. But for x-intercepts, we make y equal 0. The way I think about it is, if I'm trying to find x-intercept, that means I want to find some x value. If I'm trying to find a y-intercept, I'm trying to find some y value. So y-intercept, you're going to find a y number, whereas the other one's going to be 0. For an x-intercept, you need to find whatever x is going to be, but y will be 0. So whenever you're trying to find an x-intercept, make y 0. If you're trying to find a y-intercept, you make x 0. So the one that you're not interested in finding will always be 0. So we can solve that algebraically. Let's let x equal 0 for the first one. That would be our y-intercept. That's what we're trying to find for this one. X minus 3y equals 6. 0 minus 3y equals 6. 0 minus 3y is negative 3y equals 6. And then you would divide both sides by negative 3. These cancel out. You end up getting y equals negative 2. So you get negative 2 for your y-intercept. Then let's go ahead and find when y is equal to 0, that's our x-intercept is what we're trying to find. X minus 3y equals 6. X minus 3 times 0 equals 6. 3 times 0 is 0, so it just becomes x equals 6. This when you find intercepts is a little easier sometimes, especially if your equation is in the general form like this one is. It's a little easier to find the answers with the intercepts. Because notice when we plugged in 0 right here, we were just left with negative 3y. So if this becomes 0, it kind of cancels out and we're left with a negative 3y. Whereas here, if we make this equal to 0, that's going to be canceled out. We'll be left with the x. It's kind of a little shortcut, so some people might use intercepts to find the numbers that they need for the graph. Now remember, in order to graph a straight line, you just need 2 points. We have 2 points right here, so we can go ahead and go straight into graphing. I'm going to make my graph right here. Oops, that was a little crooked. Oh my goodness gracious. There, okay, good enough. And then we're going to go ahead, put this right here. Gonna move it up to the off center. There we go. Okay, and we're gonna assume each little mark is gonna be 1. So for this one, oops, kind of move it like that. That was a little crooked. And I'm all picky, a little OCD. I'm gonna go ahead and graph 0, negative 2, which would be right here. That's 0, negative 2, so that was our y-intercept. 6, 0, 1, 2, 3, 4, 5, 6 would be right here. That would be our x-intercept. Go ahead and trace them out. You've got your linear equation. And there we go. And remember, whenever you're using you're trying to find the equation of the line, you're graphing it, always use a straight edge or something to draw the line out. And if not, you can always just try to sketch to the best of your ability. So stretch it right over here. All right, and then put the little arrows at the end. And you got it. So let's try a different one. Let's go ahead and try the next one. All we're doing is graphing with intercepts. This one is going to be example 7. This one says graph by plotting the intercepts. And the equation is x equals negative 2y. Let's go ahead and make our t-chart. And again, we want to make x0 and y0 for 2 separate points. Each one is going to be 0. Let's go ahead and start solving for each one. If I make x equal 0, that would be 0. Oops, I'll write the equation first. X equals negative 2y. 0 equals negative 2y. And then to solve for y, you have to divide by negative 2 on both sides. But you're left with y equals 0. So 0 is equal to y, or rather y is equal to 0. If we do y equals 0 for the next point, we would do x equals negative 2y. So we make y equal to 0. Negative 2 times 0 just makes 0. So when we plugged in y equals 0, we got x equals 0. So notice here we got the same point, right? Each one of these right here, this is the same point as this point. They're both the same exact point. So since they're the same point, that doesn't help us anything. We need two distinct points. So now you can just kind of make up another problem. Again, if you look at this, x is already solved for by itself. So it's easier to choose a y value because we'll just have to evaluate it. So I'm going to pick, I don't know, I'll just do like 2 for y. So y is equal to 2. X is equal to negative 2y. This would be x is equal to negative 2 times 2. X is equal to negative 4. And there you have it. Go ahead and plot those points. The two distinct points. I'm going to draw my line here. Draw another line here. There we go. Let's move this down a little. And start graphing. I'll do green this time. So 0, 0 is in the center. And then we have negative 4, 2. 1, 2, 3, 4. And then up 2. That would be where our other line is going to be. Then go ahead and trace them out. Going to go ahead and stretch it out a little more. And there you have it. Good enough. Now, when you do it on MyMathLab, it'll do the graphing for you automatically. But try doing it by hand first. All these math problems, definitely do them by hand because it's different. Like, you learn better when you draw it by hand, and then when you go to the computer, you're like, oh, this is easier. Yes, your homework's online, and now your tests are online, but doing it by hand helps so much more in understanding it. And you can concentrate on your piece of paper first when graphing it, and then once you're done with the entire problem, go on MyMathLab and just enter everything that you had down. That's all you got to do. That makes it a little easier. Let's try another example. Learn by example, because all of these are going to have similar ones to your homework. Example 8. Now, this one just says to graph. It says graph 4x equals 3y minus 9. You don't have any expectations on this one. Like, you don't have to find X-intercept. You don't have to find a Y-intercept. It doesn't matter for this one. You can find either or. It doesn't matter. You can do set 1, 0, and the other one 0. Or you can use any point you want. Just notice it says graph. It doesn't say graph by finding intercepts. So I'm looking at this one. I might use a mix of both of our tricks. So I'm looking here. I don't know. Maybe it'd be nice to just make x equals 0. I'm not going to make y equals 0, because if I make y equal to 0 there, that makes this cross out, and then I'll be left with negative 9 and 4x. And I know that's going to lead to a fraction answer. So instead, I might choose a different value. I might choose a value for, I don't know, I can pick one for x or for y. It doesn't matter what it is. Let's just pick, just to try something out, we'll say 1. Might give us a fraction as well. But we're using the idea that we can find here a y-intercept, but we can also find a different number. It doesn't have to be the intercepts. So let's do x equals 0. 4x equals 3y minus 9. 4 times 0 equals 3y minus 9. That becomes 0. We have to join the numbers with the numbers, right? Plus 9, plus 9. We're starting to solve for y now. This should be becoming second nature soon. You want to be sure you start having this down. This is 3 equals y, or rather y equals 3. So we plugged in 0, we got 3. For our next one, this is y equals 1. This is 4x equals 3y minus 9. 4x equals 3 times 1 minus 9. 4x equals 3 minus 9. I can combine 3 minus 9. That makes negative 6. And then you can divide by 4. So it still gives us a fraction, but it gives us a nicer fraction. X is equal to negative 6 over 4. That can reduce to, remember, we can divide a 2 into both of these. That's how we reduce that. And we reduce to negative 3 over 2. And again, graphing fractions might be a little difficult, so we convert the fraction into a number so we can actually find a place to put it on the graph. You got your 2 points. That's all you need. So go straight into graphing. Do this. Draw a line right here. And plot the points. Let's see, 0, 3. Bam. Right there. There's 0, 3 and negative 1.5 and 1. So remember, negative 1, go here, and then negative 1.5 is like right here. Then we can go ahead and go up 1. And there's our graph. Go ahead and trace them out. And I'm just going to stretch it out just a little bit. And you got it. Once you get the hang of this, it's going to be a cakewalk. A lot of it's just the algebra and solving everything. But your graph should look something like that. But notice the instructions again said to graph. They didn't say anything about find the x and the y-intercepts. If it just says graph, you can use any method you want. The graph will be correct. So now you're learning a second method. You can either plug in any points you want, or you can use intercepts. We're going to learn a third method later on. Now moving on to one other example. I kind of covered this a little bit in the previous section, but example 9 wants us to graph x equals 2. So if you remember, if it's x equals 2, that represents a vertical line. So all we have to do is draw a graph. You can put a dot at x is equal to 2, and you just got to do a vertical line right there. Do a vertical line through it, and that's your answer. That's all there is to it. So x equals graphs. Remember, if it's x equals c, that would be a vertical line. That's what we learned last time. If we do the next one, next example 10 says to graph y equals negative 3. So again, draw ourselves a little graph. Remember, if it's y equals negative 3, it's going to be, instead of a vertical line, it's going to be a horizontal line. Let's see, let's move this down a little. There we go. And I'll just use blue. So you're going to go to y equals negative 3. 1, 2, 3. And then you're going to draw a horizontal line right there. And you're done. That's all there is to it. So for graphing horizontal and vertical lines, you just got to remember that little trick. Easiest lines to draw. And there you have it. That's 10.3. 10.3 only covers intercepts. So we can use intercepts. You're going to be using intercepts all the time in college algebra. You're going to be finding the x and the y-intercepts of parabolas. And if you go to calculus and pre-cal, you're going to be finding other x and y-intercepts. But the general rule is whenever you want to find an x-intercept, remember you make y equal to 0. If you want to find a y-intercept, you make x equal to 0. Because all your x-intercepts will end up being some x value, comma 0. All your y-intercepts will be 0, some kind of y value all the time. You'll be using that idea from here on out whenever you're talking about graphs. Right, then in 10.4, we'll move on. 10.4, we'll be talking about slopes and rate of change. This is like the core part of linear lines and what they are.